In this question, they say that the number of matches won by a basketball team follow a Poisson distribution. So if you let the number of matches be x, then x follow a Poisson distribution with the mean is 3 per season. And then they say that the points scored by the team in a match follow a normal distribution, which means this is another variable, another random variable about the points. So a mean of 66 points and the standard deviation of 10 points. That means if you consider the points is y, then y follow a normal distribution with the mean 66 and the standard deviation is 10. Part A, they're basically asking you about the team win fewer. That means talking about x, fewer than 6. Remember, 6 is not included, just until 5. So the required probability is x equal to 0. To the outcome, x equal to 5 only. Don't write down 6 also. So after we write that down, make sure we don't make any stupid mistake, then we can continue. There is a common term e power of negative 3, and then what inside is 3 power of something divided by something factorial. 3 power of something divided by something factorial. Then use calculator. We get 18.4 times of e power of negative 3. 0.916082058, a relatively high chance. Part B is totally not related to Part A. They just say about the probability that the team scored. That means y is larger than 70. Py larger than 70. And then have a look at the distribution. The mean is 66. Now we are talking about larger than 70, which means only one side is involved. Then we just need to calculate the corresponding standard score, and then the table. Standard normal distribution table will give us this area. So we are going to use 0.5 minus this area to get the required area here. Change the requirement to standard score. Larger than 70 minus 66 divided by SD10. Larger than 0.4. Then we use the table, 0.5 minus the red area, 0.1554. So 0.3446 is the area here. Part C say that if they win together with a score more than 7 points, then they will receive a certificate, and then a bonus will be given if there are 2 certificates or more in a season. So to get this required probability, they say win exactly 3 matches. They do not say given. So this is not fixed, it's not given. You have to put this part. The number of match the team win is exactly equal to 3. And the second stage is given win 3 matches already. And then among those 3 matches, we need more than 2 certificates, which means that it can't be exactly 2, need to be larger than 2. The number of certificates larger than 2, maybe I let W be the random variable. Number of certificates, so here we are talking about W larger than 2. Now when we consider it x equal to 3, and then given that only 3 matches have a chance to get certificates, we have to get more than 2. That means only one case. We get 3 certificates out of 3 matches. So this is relatively easy. It's because only one single case we need to consider. So the first part by the Poisson distribution, e power of negative 3, 3 power of 3 divided by 3 factorial. And then the second part is follow W, follow a binomial distribution. Now we have 3 chances, and then the probability is 0.3446. So that's why this case is among 3 we get 3, and then we success 3 times in a row. Therefore, the answer is 0.009168005. And then C2 just apply exactly the same logic. But beware the wording, they say if the team win exactly 4 matches, that means this is already confirmed. We are calculating the conditional probability. You don't need to have to consider the Poisson distribution in front. Therefore, the probability is the number of certificates larger than 2, given that we have 4 matches chance to get the certificate. It's not easy to analyze if we are considering multiple cases together, so we should separate them. The first case to fulfill the requirement is we get 3 certificates out of 4 matches. And another chance is we get all, that means 4 certificates out of 4 matches. That's easier to understand. That means among 4 we choose 3. And then we success 3 times, fail 1 time. For easy presentation, usually I will say that we take A equal to the success probability, 0.3446, and then B equal to the fail probability, 1 minus 0.3446. Usually, traditionally in textbook, we use P and Q, but I use A and B is because I can use the memory slot directly and it's helped me to reduce the mistake. So we put A and B here. And then the second term is among 4 we get 4 and we success for 4 times. Then we get the probability 0.121379753 logically. The final part, they say given that means we are going to handle the conditional probability. We have to calculate the target among all possible paths to fulfill the requirement. But anyway, they say fewer than 6 matches. Together with how they ask the question in C1 and C2, it's very obvious that they try you to separate when x is equal to 3, x is equal to 4, x is equal to 5. X can't be equal to 6 because they say fewer. Just now we already checked the condition when we win 3 matches and 4 matches. So what is extra is you need this part. We just apply the same logic once again here. We do not get the answer directly, but we just focus on this part. The probability that given we already win 5 matches and then we get the certificates larger than 2. Again, we separate to 3 cases. W equal to 3. That means we get 3 certificates out of 5 matches. Or we may get 4 certificates out of 5 matches. Finally, we may get all certificates out of all 5 matches. So, this is 5C3. Success 3 times, fail 2 times. This is among 5 we choose 4, success 4 times, fail 1 time. Finally, among 5 choose 5, success all 5 times. We get 0.226845138. So now the conditional probability is in case that we have enough certificates. At the same time, the number of winning matches is less than 6. Divided by the denominator, that means the given condition, win less than 6 matches. So this part, the denominator, is exactly the same as the answer in part A. But this part, because we have inequality here, that's why we have to separate them. We have to separate to 2 cases. The first case is we get enough certificates given that we win exactly 3 matches. The second case is enough certificates given that we only win 4 matches. Last one is the number of certificates enough given that we win exactly 5 matches. So now the numerator, we are going to apply C1, C2 and also C3 answer. Beware that in C1, we already include the given condition that we win exactly 3 matches. While here, C2 is just the conditional one. That means we still need to multiply the probability that we win 4 matches by Poisson distribution. Also pass C3 here. So the first part of our first term is 0.00916806. And then the second term, it should be ensure x is equal to 4 first. That means e power of negative 3 and then 3 power 4 divided by 4 factorial. And then apply this conditional probability. And finally, the last term, again, we just calculate the conditional one. We still need to ensure we have exactly 5 matches winning. So we have e power of negative 3, 3 power 5 over 5 factorial. And divided by the denominator, that means the answer in part A, 0.916082058. Then we get the final answer, 0.05723786. This is not a very difficult distribution questions that you should able to get most marks.